Hello, while everyone gets logged on and set up, I'll take 2 minutes to let you all know what to expect in the next hour or so. So welcome everyone. For those that don't know me, I'm James Westwood. I'm a senior consultant with Harvey Nash and I run the Yorkshire Dev practice. I'm running the event tonight with Usman Shahid. He's the managing consultant for our Newcastle office, and Tom Alexa. He's head of the Midlands Dev practice, based from Nottingham. We've come together to bring TechSpace to life. This is the latest in our series of bi-monthly events aimed at giving something back to our networks. Those that are returning will know that a big part of what we're hoping to do is put on a great event, but also create an ongoing support network for taking your career to the next level. So with that in mind, please do follow the main TechSpace page on Meetup, where you'll also have access to our Slack HQ with its event resources channel. There's some great reading lists and links from the previous events already on there. Today's event would not be possible without our sponsor, and that's Harvey Nash. Harvey Nash specialise in tech recruitment across the world and partner with some amazing brands. Companies of all sizes, to be honest, but think Channel 4, for example. And we run a number of tech events, podcasts, and the famous salary survey in partnership with KPMG, all worthwhile checking out as useful insights into the world of technology. So on to why we're here tonight, the Journey to Serverless event, a hot topic for all the companies I'm working with at the moment. I think whether they're on the journey or just starting the journey, you're going to hear from 3 expert speakers who are going to talk you through their personal experiences, some challenges and their successes. This is followed by the live Q&A with all the speakers acting as a panel. The Q&A part is reliant on your questions, so please do send them to us as the event progresses via the Q&A function on the Zoom as we carry on. We'll do our best to work through all these questions tonight. If there are any unanswered questions, they'll go onto the Slack channel and we promise to get all of your questions answered. We're hoping tonight's event meets its aim of providing useful insights and takeaways that will help you all, whether it's in your day job as a tech professional or in your personal projects at home. It remains to be said, the biggest thank you to all the speakers who I know live very, very busy lives and have given up their time to make tonight a success to be with us. And finally, a big thank you to all for taking your time out of your day to be here with us. So thank you. I'll pass you on to Usman. He's going to intro the speakers, and I look forward to meeting you all in the chat as the event progresses.
Thanks a lot, James, and thanks everyone for joining. We'll be running the chat alongside the speakers, and then there's also the Q&A. So do make sure to fire in any questions, and we'll do our best to get those answered. Either during or following. But without further ado, over to friend of TechSpace, Mark Jose from Scott Logic, to talk about Nervous About Serverless, a consultant story. So over to you, Mark. I'll just hand you the reins.
Lovely, thank you. And then I guess I should be able to share this then. That one there, I think. Hopefully everybody can see my screen. Can everybody see my screen? Yes.
Yeah.
Great stuff. Fantastic. I guess so. I'm Mark Jose. I'm a consultant at Scott Logic. If anybody doesn't know Scott Logic, we're a consultancy. We're based in Newcastle. We've got 5 offices across the UK, with an office in Copenhagen as well. We're headquartered in Newcastle. I've been with Scott Logic for about 7 years now. But I've got probably 20 years in software development. My job title at Scott Logic's technical principal, but it's pretty much a badge that they put on me so they can sell me out to clients. So, but my day job is pretty much technical architect with a stroke of delivery and stuff in. I guess some of my most recent work is in the Google Cloud platform. However, I've got quite a bit of experience in AWS as well. And some of the more recent stuff I've been working on is moving from some on-prem hosted services to I guess a truly cloud-native cloud functions type architecture. I mean, I think you're going to get a few talks tonight which are technical. Mine's going to be a little bit about being a consultant with regards to speaking to clients about serverless. I'm going to be a pedant, sorry, Usman, about the title of this actual thing being the journey to become truly serverless. I'm going to question a little bit, what does that mean? Can we ever be truly serverless? Because everybody's heard that phrase, it's just somebody else's computer, right? And I guess there's lots of levels of serverless, but there's lots of levels of servers. I mean, starting from like actually having a computer or app on your site, and actually a lot of our clients that we work with still have on-prem metal. They have their own data centers in the basement of their building, and they have their own servers and a team of people to maintain those. And then I guess the next level is outsourcing that to a data center, I guess, and then actually containerizing some of your stuff in the data center to actually app engine type style services where you're actually paying for compute power but running long-running services to actually truly serverless, i.e. cloud functions where you're paying for compute on a function level. But I guess the underlying thing is we're still using servers there. Again, they're just somebody else's. And actually, how do as a consultant, how do you explain that to what is generally non-technical stakeholders or the people signing the checks? That tends to be doing the tech. I'm not going to say it's the easy bit because obviously there's lots of architectural concerns there, but actually the difficult bit is actually explaining why serverless is a good thing, or actually sometimes a bad thing, not the right thing for doing what the clients do. I guess a little bit around understanding some of the clients we work with. We tend to work with financial clients. We boast a lot that we work with, at any point in time, we work with about 7 of the top 10 investment banks in the world, which is great. The downside of that is if you've walked into any investment bank, you'll tend to find they've sometimes got their little challenger breakout type organizations which are doing modern stuff, but actually the core of the bank is pretty old from a tech point of view, from 30-year-old mainframes. There's an underlying thought that basically if we do things ourselves and keep it in a bunker under our building, we have a team of 5 people maintaining that live, that's actually going to be better for us because we have control. And actually control is a real issue for us, getting large investment or enterprise organizations to release a bit of control is difficult because it's that holding on to things. There's a lack of trust in the public cloud. There's a lack of trust in the cloud generally. On-prem is more secure, is always the thing we hear. And the cloud is too public. The cloud is insecure. I guess those sorts of conversations. I guess my comeback there is always, how is a team of people, 4 people, looking after a piece of metal in your basement more secure or actually more reliable or more stable than a team of tens of thousands of specialists in that area looking after multi-regional data centers around the world as part of a big piece of infrastructure. So then the second you come up with that, you get the other thing about, oh, well, hang on a minute, we've got to keep our data in certain regions. And then, well, that's possible. But a lot of arguments can be addressed, I guess. Why is serverless appealing for our clients? Well, actually, a lot of the big banks and a lot of these financial institutions, and actually I'll caveat with, we don't just work for the banks, but I'm using the banks as a specific example here. It's appealing because banks deal in process and they deal in workflows. And actually, even when you look at what they're running on the metal in their under their building, in their data centers, those workflows are their methodical, logical workflows. You can explain them with a flowchart. And actually, they use workflow management engines, which are out there with pieces of software to manage that. And actually, when you start looking at truly serverless, I'm going to use that phrase, truly serverless. I'm going to keep using truly serverless architectures. You tend to find their workflows. You'll have something that triggers another action, that does something that then triggers another action, that does something then triggers another action, that makes a decision and might split and parallelize things and then might bring things back together. And they're the sort of things that, the sort of architectures that actually live in these banks' processes. I guess, so then if that's the point, why wouldn't you choose serverless as a financial organization? Why wouldn't you choose serverless? This is a service architecture that mirrors your process. Therefore, there's pretty much a one-to-one relationship with the process and how you implement that. Imagine you're a Forex company streaming prices. So in some cases, for cloud functions, truly serverless, cloud native services, aren't that good at handling long-running tasks. highly available things, long-running tasks, streaming, that sort of thing. So if you're a Forex type company where you're managing streaming prices all the time, you're going to need to do a lot of streaming and you're going to need things. You might be better off going for probably not on-prem metal, but at least some sort of hosted service rather than native cloud functions or the like. So I guess the key thing is, as a consultant, you have to be a little bit on their side. I really understand the use case. It's not always the correct choice, but serverless is obviously another tool in the toolbox, and it should be considered like any other technology, the same as the discussion between using a relational database or a document database. You know? I use analogies a lot. So anybody who's heard me talk about anything before or who spoke to me, there's a few people on the panel here who know I'm a bit of a petrol head, and all of the analogies that I use are all car-based. But I'm going to take a bit of a divert from the norm, because I thought, can I come up with a car analogy that is serverless versus on-prem? And there's a really obvious one. There's a hire car versus owning a car. But actually, I tried taking that analogy down a path and it didn't really work. So I'm going to talk about something that we probably haven't seen much of, but we're probably looking forward to. And that's holidays and annual leave. And I guess if you're going to go on holiday somewhere, you're going to do a few things. How many people own a villa currently? Probably not many. There's probably people who've dabbled in timeshare, or there might be the odd person on the call who does own a villa, you know. But you'd own a villa if you go to the same place regularly. And generally, if you're going to go on holiday, you want to go to different places. You basically want to change that up a bit. So what's the pros and cons of owning a villa? Well, I guess the pros, it feels like you're at home. You can make the place your own. You have your own stuff there. You can leave things there and you can come back to it and they'll still be there. And what's the cons? What's the downside? Well, the downside is obviously you've got to maintain that villa. You've got to pay to have it painted. You've got to pay to replace things when they break. There's quite a large upfront cost because you've actually got to buy the villa in the first place, or rent the villa every month, whether you're there or not. You've probably got to staff the villa, so you've got to have people to look after it. And you also, when you're there, you're probably going to try and fit in with that community, you know, around the villa, so other people around the villa. A lot of the people I speak to are quite senior stakeholders within these large investment banks, and a lot of them do actually have villas or holiday homes or flats elsewhere. And actually, I guess they can relate a little bit to this. But when you compare that, if we say the villa is your on-prem metal, I'm sure you all picked up on the analogy now because I explained it was going to be an analogy. The villa has all of the same pros and cons. Generally, when we go away, we stay in hotels. So let's say cloud functions are hotels. Most people stay in hotels. The reason being is they don't want to own a villa. They don't want to pay for that cost all of the time. They want to pay for the hotel and they want to go when they get there. And actually, stopping in a hotel has a lot of pros. Multi-region support. You can book a hotel in any region you like. You don't have to go to the same place all of the time. You only pay for what you use. So you only pay for the nights you're there. You're not paying for the nights when you're not there. Every time you leave and come back, somebody's made your bed. They look after it. It's maintained, you know. And you can change your mind often. You go to a hotel, you don't like that hotel, you go to a different hotel because it offers the services you want. You don't have to maintain it. It's maintained for you. And then I guess you can stay in different hotel chains depending on your requirements. But staying in hotels has a few cons, right? If you've got your own villa, you can have the TV you want. You might have a TV that has Apple TV installed and you've got an Apple iPhone. And when you get there, you know your Apple iPhone will be able to share content on your TV. Or if you rock up at a hotel with an Apple iPhone, you'll probably find there's a Samsung. I don't know what it is, but all hotels seem to have some deal with Samsung going on. They'll do Samsung TVs, and you're probably going to struggle. You're going to have to be compatible with their technology. So you get what you're given. The other thing is you can't leave your stuff there. You can't store state. You can't leave your stuff there because when you come back, it'll be gone. Somebody else will have had the room, or it'll be in the lost property. You have to go and find it. And then when you leave, somebody else gets to use that. And sometimes you might not have access. You might book too late. And actually, with Google recently, you actually try and spin something up and it won't let you because there's not enough knocking about. So I guess hotels and villas are where I go when I'm trying to explain the beauty of serverless or the differences between serverless and on-prem and service. I'm not going to go through and explain how the analogy relates to the real thing. I hope everybody on this call is the sort of person who can pick up on that. But that's how I approach explaining what serverless is to our clients. There is some middle ground which I haven't covered, of course, which timeshare is obviously Kubernetes and Docker. But there we go. We'll leave it there. That's me.
Thanks a lot, Mark. I don't know about everyone else, but it's just made me want to go on holiday a lot more.
Sorry.
No worries at all. Cheers for that. I will jump back on if you can stop share. Fantastic. So next up, we've got James Hall from Parallax, who is going to be giving us a talk. I'm just going to transfer the reins over to you, James, and there you go.
Perfect. Thank you very much. So hopefully you can all see my screen.
Yes.
Nice. Perfect. So I'm going to be talking to you a little bit about our journey on serverless. So yeah, we started off with a football campaign and right the way through to today where we're building large sort of energy portals and things like that. So if you don't know about Parallax, we're a digital transformation agency. We take big hairy problems and turn them into apps and websites and things. We've been running for about 10 years. One of the directors and founders there. We've got a bunch of logos here, as everyone does. This is back when, remember, you could stand next to each other outside? That was good, wasn't it? So yeah, hopefully we get another one of these photos again soon. So personally, I work on some of our more unusual projects, one of them being Key, which is a street lighting project. So we've got about 16,000 street lights in Aberdeen, which are hooked up to the internet via radio, and we do over-the-air firmware updates and cool things with these. So it's, yeah, nice, big, meaty, techie project, but I like to sort of get to grips with all the new tech that we can use on things like this. So our first big serverless project, we'd actually dabbled with it at an AWS meetup, maybe in 2015. So it was actually another partner of ours that came to us with this problem. Effectively, it was David Guetta's new song, and it was UA for Euro 2016, and they wanted a way for all his fans to sing along to this new single. We'd been playing around with Lambda. AWS Gateway, API Gateway, just been released, and we basically modeled out some of the architectures that we could use. The problem is that they said that they're going to read this URL out on TV. So immediately we had a problem here. We started sort of modeling out what it might cost in a sort of traditional web setup. So we had EC2 nodes, auto-scaling groups, you know, your bog standard kind of stuff. The problem with this is that you have to sort of figure out what your maximum load's going to be and spin it up to that. Back in the day, sort of spinning up new EC2 nodes was actually quite costly in terms of time. So ideally, you'd want to sort of over-egg it. So you'd go, right, we're going to spin up 20, 30 servers, and we're going to leave it running the night before. And then when it gets spread out on TV in the morning, we'll have enough capacity, and we can scale up a little bit maybe, or down if we've gone well too far. We started toying with the idea of actually using these new AWS services in what was at the time a bit of an unusual way. So as I mentioned, API Gateway just come out. There was this framework called JAWS. I think it was in like pre-release alpha or something like that. And we were chatting with those guys a lot, but we actually reached out to AWS and we said, look, we've got this potential project. We know there's these limits on Lambda for current execution. Can you knock those limits off for us? And then we did a bit of digging and tried to sort of figure out what that might look like. And we came up with this, which is pretty bog standard serverless architecture that you'd use today. So our biggest concern was, well, is it actually going to run the workload that we need it to? So the initial page all comes out of S3. So it's S3 and CloudFront, so nice and quick. And then during the life cycle of using the application, so you record yourself singing, you make some customized artwork, which can be shared on social media, you download the different languages, all those sort of happen staggered. but we need to make sure that we can actually hit the request a second that we're looking for. We're using a service called Blitz.io, which I don't think exists anymore, but it's really useful to sort of test this out. And one of the interesting things we found is not only does it hit those requirements, it actually gets quicker the more traffic you throw at it because it warms the containers. So immediately we were thinking, actually, yeah, this is probably a pretty good fit. So we built the thing. We got videos of David Guetta. We had him singing the song. This bit in particular was quite fun because WebRTC was pretty new back then. So in Safari, we actually had a Flash SWF fallback. And then on mobile, you upload a little video and yeah, all the different implementations for different browsers and things like that. But because we sort of folded the waiting time into the experience, you didn't really notice it. So you get a nice quick loading time. First of all, you can log in with Facebook. We go and tell Facebook to pre-fetch the org images that's nice and warmed up. And then everything just flows into a big old DynamoDB table. One of the challenges was around, obviously this is global, so we had a Lambda function to generate the actual album artwork image itself. We had a small one for English-speaking countries, and then we actually had to dynamically load in Unicode fonts from S3 as it booted to do Japan, China, etc., because the font's bigger than the Lambda maximum size at that time, which was a fun hurdle to discover halfway through writing a project. But yeah, there you go. So we actually managed to get the 1 million fans to sing along. It went swimmingly. Yeah, it was a successful serverless project. So we ended up using this model for a lot of our spiky traffic campaigns. So anything where we weren't exactly sure where it's going to spike to, we don't want to sort of pre-warm a load of infrastructure. But what we didn't do was move our existing applications across to serverless because that would require breaking them into bits and yeah, all that kind of fun stuff. So a few years ago, we decided on Kubernetes, or timeshare, as Mark says. Now I feel that Kubernetes is almost like a stopgap solution for a lot of things, because all we're really doing is it's making these sort of legacy applications run on little pods in the cloud. And it kind of feels like it's almost the wrong timing. Like you could almost skip this step if everything was just a little bit further along. So this was probably about maybe 4 or 5 years ago, we started working on a Kubernetes infrastructure. The issues that we have with our Kubernetes infrastructure is that it's quite a lumbering beast. It needs a lot of nodes underneath to have a sort of minimum viable deployment for failover and all the rest of it. So we get all these crazy ideas for startups and new apps and IoT projects. We build them in our environment, and then the client goes, right, we've got some investment. We want to spin up into our AWS account. We help them build a team around it. But then we have a problem, because now we need to spin up an entire Kubernetes infrastructure for this one app. And it probably doesn't really need all that, because, well, it just doesn't. It's great for us because we're running maybe hundreds of different applications, all different sizes, and the cost of running the infrastructure for us is fairly minimal. But if you pass that on to the client and they're having to deal with all that sort of stuff, then it's not great. It's also not so great if you want to sort of keep your base costs lower. You're talking thousands of dollars a month rather than hundreds, which some companies will want to run on at first. So it's not so great for that. So that previous infrastructure we nicknamed K-Build internally. So we moved on to building this S-Build project, which is built on top of the serverless framework, which we used on the David Guetta project. The idea behind this is to just sort of make a standardized way where Parallax can roll out new serverless applications. So pretty much all of our new builds now are deployed in this way. And out the box, you start with the boilerplate and it gives you custom domain with SSL. It obviously goes and sets up all the CloudFront. You get DynamoDB for your tables. You get sort of SQS queues with dead letters so you can retry any jobs. Sets up any databases that you need, and the credentials are all pushed into environment variables. We're really big on just trying to automate as much as you can. I think getting a good thing about serverless is it just force people to set up a proper deployment pipeline. So it's just as easy to spin up a local, well, a sort of QA environment or a development environment as it is to spin up the production environment. We make sure that we have all our sort of automated tests baked in there as well. And we have sort of separate URL structures for sort of QA and production. Some of the challenges for this S-build thing is if you're sort of taking a legacy app and it's not already one of these 12-factor apps where you're doing all the right things, like you're storing things in S3, you have environment variables, that can be a bit of a challenge, but I think it's definitely worth working through those if it's a smaller app and just getting it ported across. So one of the apps that we've built in a serverless manner recently is this Companions app. They aim to tackle the loneliness epidemic that they think is going to follow the coronavirus epidemic. It's kind of like a matchmaking service. So it pairs people up and you can go around and cook with someone or go for a walk or something like that. It's recently featured on BBC Click, but it's got video calling in there. It's got peer-to-peer payments, messaging system. It's got whole marketplace, discount codes, all the things, but that runs absolutely swimmingly on serverless. Yeah, so as I mentioned, recently featured on BBC Click. We also deployed an energy portal recently on serverless. So this is, I think they're the 3rd or 4th largest small energy supplier outside the big 6. So we actually found that serverless in sort of monitoring and stuff like that isn't as great as it could be. So we actually built a custom New Relic layer that we can actually put on the serverless deployment, because we actually do quite like New Relic, even though the pricing could sometimes be a bit all over the shop. They've actually got I think it's per 100 gigabyte pricing model now, so it's not based on number of servers, which with serverless would be absolutely nuts. In 4 or 5 months, we took £7 million in one-off top-up payments, and that just sort of trundles along. It doesn't need any sort of any sort of infrastructure support. Like it just runs basically. So there was a hard requirement for that to run in their own AWS account because of regulations. Because it's an energy company. Yeah, it needs its own kit basically. And I imagine the Mark has similar issues with banks and worries around things running in shared accounts, things like that. So what's coming up? What do I think is coming up for serverless? So I definitely think that Lambda supporting Docker, it sort of opens up some potential use cases, also some potential misuse cases. You might start seeing people grabbing big old VMs and trying to shove them into a single Lambda function. I think for many organizations, especially on greenfield projects, you can almost skip the containerization or small VM step and go look straight into serverless deployments. I think you'll avoid a lot of headaches doing that, especially things like that you don't really think about with small VM is, you get this with Docker as well, is upgrading dependencies and packages and things like that. So going straight into serverless does remove some of those headaches. It doesn't eliminate them entirely. I think there's some pretty exciting times ahead, and I do think that monitoring and observability could be improved. CloudWatch is not the best place to look at what your apps are doing. It might be better in G-Cloud, I don't know, but in AWS at the moment, I think there's some improvements that could be made. And yeah, final note, we're hiring. So if you if you want to work on some cool stuff, hit me up, and my details are on there. So thank you very much.
Thank you very much, James. I'll just leave the details up there for a minute for anyone that wants to take a note. While I've got you, James, if CloudWatch isn't where it needs to be in terms of monitoring, is there another solution? This is where I'm not in the tech, so I don't know if that's an obvious question to everyone on the call, but
yeah, well, we kind of like New Relic for application performance monitoring, but things like Datadog are great. Like, unfortunately, the big lumbering, expensive options are really good. But yeah, it'd be great if there was a cool startup that did something a bit more, yeah, a bit more cost effective, maybe.
There's a few, yeah. Epsagon, Lumigo, and Thundra are pretty good too.
Oh, nice. I'll have to check those out.
That's if you're in AWS, of course. If you're in G Cloud, then of course they had Stackdriver for a long while, which was a third-party product, but they've actually bought Stackdriver now, and then they've split it all out into Cloud Trace, Cloud Logger, something else, like 6 other products with the word cloud in front of them. I think it's quite a nice little stack though.
Nice.
In GCP.
Nice.
good stuff. Well, thank you very much, James. And we'll transfer over now to Dan Pudwell from Grid Smarter Cities. Over to you, Dan.
Thank you. Hello, everybody. Good evening. And I'm going to talk, I guess, a little bit more about a project that we did at Grid. It's a bit old now. We started this maybe 2 years ago now. It ran for about 8 months, kind of development and kind of testing in production. So it's kind of not quite a deep dive, but it's a medium dive, I guess, into how we ran the project, what it was all about. The focus is a bit more on the cost, but there are some other kind of benefits we realize sort of as we go through it. So I hope everybody can see that presentation. Is that on the right page? Yeah, cool. So so we basically built a truly serverless application, 100% serverless. In roughly 6 months' time. There was a lot of kind of user research going on at the same time as well, and feeding into it and back and forth with some other things. So yeah, and it's, you know, roughly £100, which includes, you know, all the development, build, and kind of running through production as well. Sorry. There we go. So yeah, we'll talk a bit about what this ADAPT project was, the kind of technology that went into it, the architecture, and kind of how we built it. And then we'll talk a lot about the bill kind of at the end, and maybe a few surprises, or maybe not at the end as well. So ADAPT was this Assistance for Disabled Air Passenger Travel project. It was all about, sorry, I'm just going to move that out of the way. It's all about helping disabled passengers when they need assistance. So a lot of times when you go to an airport, you might see people in wheelchairs, and they're kind of cordoned off or in a certain space. That's because they kind of get put into what the airport people actually call pens. They just put them there and they get left. They might get checked on maybe every couple of hours, but it's not a very good experience at all for the passengers. So we're trying to let them be a bit more, well, like just people, really, you know, going about their business. And then when they do need assistance, they can ask for it. So yeah, this is a few news headlines that were kind of going around at the time. So there's a lot of motivation, I think, in the air industry to make this a better experience for passengers. So yeah, so there's 3 kinds of users: the passenger who comes into the airport, there's an assistant who provides the physical assistance to the passenger, and there's a coordinator who kind of receives these requests and then tries to get the correct person to give that assistance. As we said, the current passenger journey, they come into the airport. They're not really, you know, the airport doesn't really know they're coming. So they have to find a help desk, present themselves. If they are mobility impaired, so in a wheelchair, they take you to these holding areas or pens. and they're kind of just left there. So they can't shop, they can't go to the toilet. Probably a lot of lost money in, pints and things like that at the bars for disabled passengers. Lots of shops at the airports. I'm sure they want to go and buy stuff and have a pint with their friends before they leave. And they can't really do that. So what we wanted to do was trigger a geofence as the passenger was getting close to the airport. So then the airport is alerted that somebody's on their way. To have the passenger only request the assistance when they need it. That would then notify the coordinator at the airport. They would assign the appropriate person. The assistant can then find that person on an internal map. So at the time we partnered with an internal mapping provider that did Heathrow Terminal 3. And then, so it showed each person on the internal map, either the passenger could see the assistant or the assistant could see the passenger, and obviously quite secure as well, so nobody could see other passengers or other assistants at any time. And then two-way messaging in between to let people know, if they had any messages between them. Maybe they, I'm wearing a red scarf or something, it help identify people a bit better. So we did all serverless stuff. So, Lambda, Dynamo, API Gateway, Cognito, a bunch of other kind of services in there. Using API Gateway REST, so the normal, I forget what it's called now, the resource from CloudFormation. There's also the V2 version, so WebSockets. That was quite interesting to work with for the first time. Again, NoSQL databases, so using Dynamo. We were using push notifications from Android and also to the browser as well. So we used this other thing called Vapid, which was quite cool to send a push notification out to a browser. Again, the internal mapping was provided by another company. And yeah, it was all serverless. So yeah, Mark, I think, covered the kind of the why and the other bit around servers are, they're still present in a serverless architecture, they're just not yours. The main reason we used it was one, to keep costs down, and two, because we knew we weren't going to have a huge amount of traffic. It wasn't for the auto scaling or anything like that. It's mainly for speed of development for us. We thought we could get things going faster by writing less code, essentially. We'll come on to that. I don't think that was entirely true, but we'll come back to that at the end. So the architecture of the kind of back end of the application, 3 microservices. So something to handle kind of the main requests. We had a service that dealt with any outgoing notifications, and then another service to handle the profiles of the disabled passengers. We did a multi-account kind of strategy as well. So this is an AWS kind of recommended practice where you segregate your testing environments away from your production environments. So we had them in different accounts. Full CI/CD pipelines. And then user interfaces, we had 3 Android apps, 1 for each of the users, passenger, assistant, and coordinator, and also a React web application as well for coordinators as well. So that's what it looked like. There's a lot of detail in there, but that is kind of the full application. So the blue lambdas were the WebSocket kind of action handlers. The green were either for just kind of handling other actions like streams off Dynamo databases, or the REST requests. So you could see maybe in the middle, there's a connections table. So when a WebSocket connection was made, we'd store that connection in that table, and then we'd send a stream out from that list that would update coordinators' list of assistants or list of passengers that are coming into the airport. And then notification service was up here. So that handled, Firebase push notifications going out, or any the Vapid push notifications going out as well to the browser. And we also used SES for any outgoing emails as well. Interestingly, this notification service, after 2 years, we're still using that and using that with other products as well. So we've kind of reused that microservice in other contexts, and it's quite nice because it's the same interface that we've exposed to other applications, whether we're sending a push notification or an email, and it just handles kind of everything we want to throw at it. So that's been quite good. On the left-hand side, you can see the kind of the interfaces. So we use this living map, internal mapping SDK from them, and typical kind of S3 React application with CloudFront and Route 53 on top. This is our build process. So I think it kind of all stems from GitHub. So when you make a pull request in GitHub, that will trigger this kind of pull request build. So that runs a completely kind of separate environment. It will spin up everything that we saw in here, kind of in there. So that's quite nice in a build process. You know, it just does it all, does all the tests, and then kind of tears it back down again at the end. So we do the same thing in all three services. So you can see here, we actually have 6 different AWS accounts for that. We have expanded this now. So all of our services now have 3 accounts, a dev, a staging, and a production account. So all the pull requests happen in a dev account. Any merges get pushed to staging. If staging is happy, that's kind of what this master bit is. That gets pushed out to the production environment straight away as a continuous deployment process. It's really nice, actually. So, you know, if you need to, you know, deploy a hotfix or, you know, something's gone wrong, you can get a change out to production in this case, I think it was less than 10 minutes. So costs. So this is our entire bill for the entire time that we were working on this project. So as you can see, you know, monthly costs for running the notification service in total, you know, for 7 months, 6 months, it's quite low, $17. You know, with $137.48 for the entire, you know, 3 microservices, 6 different AWS accounts, hundreds of builds. You know, this covers everything. So it was the highest one there was kind of the Adapt staging account. And that's probably just in build time, I think. Code build turned out to be our most expensive service. So if we look at by service, you can see, yeah, the staging where we do most of the testing started to, you know, account for most of the cost, but you can see by the end of the month, sorry, the end of the kind of lifetime of this project, the production service was getting used a bit more. And then if you break it down by service, yeah, you can see code build doing the most damage to the bill. CloudWatch, as Mark said, it's not a great tool. It's gotten a little bit better, but we have switched over to Epsagon now for our kind of logging monitoring. It does point to CloudWatch logs, but it's much easier to find stuff if you use Epsagon as kind of a search tool first. Yeah, tax is actually the 3rd highest bill on our services list, which is quite funny. I don't know why AWS call that a service, but whatever. Interestingly, I think over the whole 7 months, we only paid 1 penny for our entire compute cost, which is amazing. Route 53, 50 pence, you know, that's nothing, isn't it? So, so yeah, some really good stuff there. The ECR costs now, we have done completely away with using ECR. We used to use a kind of a custom build image for code build, but we're now using kind of standard AWS images, and we just load dependencies at build time. So yeah, that isn't a cost for us anymore now, which is quite nice. And then, yeah, so this is the cost by service, CloudWatch, code build. As you can see in July, we did a lot less builds because we were more running kind of a production service. And it was more about kind of, you know, getting that user feedback than deploying new features. Yeah. So if we compare that using another, you know, server-based architecture, even if you use some small service, T2 maybe, it's going to cost quite a bit more. In this case, it was, you know, almost 10 times the cost. If you're going to be running, you know, databases, servers, if you want to run something like Jenkins on your own EC2 instance as well. Yeah, and then you've also got to figure out how to do all the other stuff at the bottom: load balancing, networking, availability, scaling. As James said, all that stuff is just taken care of for you. You don't even need to really think about it when you're doing a serverless architecture. So as we went through the project, we did learn some things. So the size limits on API Gateway and Lambda. So Jamie said you had the same problem as well. So ours was mainly in profile pictures. You know, somebody took a selfie and tried to load it. I think at the time there was a 5 meg limit on API Gateway or Lambda. I can't remember which one. So we worked around that a little bit by using S3 kind of prefetch URLs, which is quite a nice little thing to do. The Dynamo stream failing was quite tricky to figure out because it was just constantly retrying things for 24 hours. So you wouldn't see anything new coming in, and then suddenly after 24 hours, it would just start working again. And it took a while to figure out. So we needed to have some better error handling and for handling that one. WebSockets, they're hard to test, kind of due to their asynchronous sort of nature. So, you know, you send it a message and then we're expecting to get something back, but we don't know when that's going to come back to us. You know, there's not a request response kind of structure. So we actually wrote our own async testing library and open sourced it. So I'll show that at the end. We've actually open sourced a few things which could maybe help some other people as well. There are some other nice things you can do with API Gateway. So rather than sometimes you want to go from API Gateway to Lambda to Dynamo, it's a very typical pattern. You can actually go API Gateway straight to Dynamo, but we don't really recommend it. You have to use a VTL template in your Lambda kind of request structure, and it's impossible to test. You can't unit test it. If you've got some tricky logic to go in, it's almost impossible. So I would strongly recommend, even if you're going to save, you know, maybe 100, 200 milliseconds, it's definitely worth it just for the robustness of putting a Lambda bit of code in there and being able to unit test that. The other last thing about Dynamo, it's not a SQL database. So if you're trying to do anything with relationships, you can. There's a great talk by a guy called Rick Houlihan, who's like the AWS NoSQL wizard. He does great talk on how to model relationships in Dynamo. But it is very hard. And it requires you knowing upfront a lot of information, you know, basically all of your access patterns and how you're going to be querying that data. If you don't know that, just go with SQL. There's a great Aurora Serverless offering from AWS, and they're coming out. Well, they have come out with a V2 of Aurora Serverless. I don't know what the differences are exactly. We're still using version 1, but it's quite easy to use, and there's a data API as well, so you don't even have to figure out your own connection or pooling or anything like that. It just does it for you. So yeah, I mentioned the open source stuff. So you can look on GitHub. We've got this PYWSI test. I don't know who came up with that name. It's kind of terrible. The Python serverless template. It's a bit like what I think James was showing at the end of his talk around how they start projects. So that's how we start projects with our Python serverless template. There's a few, kind of really Mickey Mouse sort of AB lambdas, so Dynamo tables, full kind of CI/CD pipeline set up in there as well. It's quite nice. An AWS Lambda decorators library for Python. So it'll extract events that are coming into Lambda from API Gateway, let's say, do all the validation of those parameters, add cores, because cores and Lambda and API Gateway is always a bit of a problem sometimes. And it'll do all your logging and exception handling as well. Saying that, there is another one I've just been pointed in the direction of, the AWS Lambda Power Tools, I think it's called. Does kind of the same thing, but that one's actually maintained by AWS. So I'd probably recommend the AWS one, but ours is pretty good too, I think. And then there's an AWS DynamoDB parser, because when you call when you call Dynamo, it doesn't give you back data in like a nice kind of key value kind of format. You get like some kind of type of the key and some metadata and some extra stuff that kind of gets in the way a little bit. So this sort of strips out a lot of that stuff and makes it a nicer kind of JSON format. Won't go to questions just yet, actually. I'm just going to show you my slide for a second. What I am going to show you is, if I just move this over, this was a retro that we did on the end of the Adapt project. I didn't remember we had done this, and a colleague just kind of pointed out to me yesterday because he was going to delete this retro board. But I thought it would be great to share with you guys. So you can see the things that did go well, that Lambda is usually very simple code, small functions. Yeah, the VTL templates, again, we recommended against them, but they are great because if you can make them small enough and there's no logic, they are quite fast, great for performance. The speed of development was really good, but I think it takes a little bit of time to figure out how some of these services work together. Yeah, and then as we go through, there's maybe some negatives there, but we do like to be very hard on ourselves. So some stuff was like WebSockets documentation. There wasn't a lot of that at the time, I think, in the AWS docs. But yeah, so there's a lot of things that we've got that we're actually doing better now, as we took kind of action items and sort of took those into the next project. But yeah, that's it. So I guess I'll stop there if there is any other questions.
Thank you very much, Dan. We've had a bunch of questions coming in all the way through. One specifically for yourself from Shoaib on the call was how many devs or DevOps were working on your project? Because it was pretty impressive that you did that in 6 months, and a smiley face.
All right. Okay. Cool. So we had a dev team of what was it? One mobile dev, one front end dev. I think there was 2 or 3 kind of what we call back end devs, and we didn't actually have a QA on the project at the time. Normally we would. I think at the time it was just a resourcing kind of issue. We didn't actually have anybody available. But we don't have any specific DevOps people either. The philosophy that we like to have is that DevOps is not a, well, it is a role, as in, somebody kind of needs to do it, but it's not a specific role. We don't have a specific DevOps person. It's everybody's responsibility in the team. It's, same as QA, everybody is responsible for making sure that the code they write is good. So everybody writes the unit tests and the integration tests. And so that could have been, again, this was almost 2 years ago now, another reason why we didn't have a QA on the project. Interestingly, we didn't have any kind of defects during any production testing. We had one usability issue relating to the timeout of the jot, but that was it.
Good stuff. I really hope that made more sense to people on the call than it did to me. And just a final one that's come in the chat while you've been talking, Dan, before I pass over to Tom for the quick Q&As that have come in. When you say account, do you mean I am user or an entirely separate AWS account?
Entirely separate AWS accounts. Yep.
Brilliant, good stuff. Tom, over to you, please, if you can rattle us through the Q&A that have been coming in.
Yeah, absolutely. I mean, as sort of Dan's been answering questions, I think there's been plenty more flying in for that. So I don't know whether we should sort of just start there to cover that off and then cover on, over some of the sort of more general questions that came in. So, just one that came in here from Martin. There's sort of one of the things that has been noticed, Dan, is that you've not mentioned any of the costs for the quota guard or buying a static IP address. And it's, how did you get around that issue without paying any money?
Well, we didn't have a static IP address. In testing, we just used the S3 URLs. And then in production, we had I don't know, I think it was like adapt something.com or something like that, which was just routed through Route 53 to CloudFront to the S3 bucket.
Okay, again, I hope that made more sense to the rest of the guys on the call. But and again, just one from Phil that was just around kind of your use of 3 different AWS accounts. Was there any particular reason behind that, or was it just a cost saving aspect?
So there is a cost saving aspect to it, which was great because you get the free tier applied to every AWS account that you use. At the time, we were talking to AWS a little bit around, we'd go to like their dev days or their builder days or whatever they were called back then. And it was recommended by them to kind of set things up in that way. It's kind of nice to keep your production account and data separate than everything else as well. So you know that there isn't going to be any kind of leakage or anything like that. You can also restrict certain users to production accounts, and everybody else can kind of access staging or development as and when they need to. So yeah, it's good for security, it's good for cost. It does make it trickier, obviously, in running things. So you notice, we have our staging builds triggering a build in production, so you have to set up cross-account permissions. Once you kind of do it once or twice, it's actually fairly straightforward. The Python serverless template that mentioned earlier is open source. If you run those CloudFormation templates, it actually sets it up for you so that you don't even, it just does the cross-account permissions.
I don't want to jump on your question, Dan, but actually from I guess a governance point of view, in the sort of areas where we work, there's a lot of audit. Having 2 accounts is actually the recommended approach as well in Google Cloud, due to the fact that you actually want to be able to pay for your business as usual prod release completely separate to the capital cost of development. Being able to separate the costs by separate account is really good.
Great. So I suppose following on from that, kind of one of the first questions that came in was, as a consultancy, how do you work with large governments or NHS clients to get them into things like serverless? And from your experience, what are the challenges that are sort of involved in that, and how have you overcome them before?
Well, I mean, I guess the biggest barrier for us, and actually I talked specifically about, I guess, our financial clients. ScotLogic was born out of Lehman Brothers, essentially, way back when. So probably 60% of our business is still financial. But actually the rest, pretty much the next big chunk is actually government. We do a lot with NHS Digital, actually. We do a lot with the DWP. And Foreign and Commonwealth Office and a few other government organisations. So we do work with all those larger clients. They seem to be very, very different and very, very similar to the financial industries in a lot of ways. They're very, very different in that you tend to find there's a completely different culture within those clients. A lot of the government organisations now are doing the right thing. I guess there's an aversion to doing the right thing in the financial clients. But it's still the same challenges when you get to the person who has to, I guess, sign the check to say, we're going to spend X amount of money on building this thing in something that's quite modern and new. It's that convincer, isn't it? It's that reassurance that it's the right thing to do. And I guess the fact it's the right thing to do is because the only way we can sort of say it's the right thing to do is by showing that we've done it before and it works. But if it's something brand new, how can you show you've done it before? And what you really need is you need some people to take a leap of faith. Luckily, we have those clients as well. So what we can do is we can take the clients that have taken that leap of faith and say, look, here's a case study. This is what we did. Pretty much like how Dan shared the project that they did, Grid, and say, look, this works. And this is how we would implement this within your organization.
Fantastic. And I suppose, question that kind of came to my mind, obviously, appreciate you guys seem to have spoken a lot about AWS particularly as that sort of solution, but what would you say are kind of the key considerations that if a company was looking to embark on a transformation, serverless transformation, the key differences between them and why one might be a better solution for that particular organization?
Sorry, is that to me? So I guess
the group,
I guess from a consultancy point of view, a lot of our clients are large financial institutions. Therefore, they're pretty much multi-cloud. We don't find if they're going to go into the cloud and they're going to buy into the cloud, they're going to buy into multi-cloud. They're not going to stake all their money on AWS or Google. AWS is by far the most widely used. The second one tends to be Azure or Google. Google, probably not so much market share unless it tends to be the audience. If it's one of these small breakout sort of challenger type groups within a large organization or a challenger bank, then they tend to be more Google. Whereas actually if there's somebody who's actually basically got Microsoft on every desktop within their 30,000 employee organization, the chances are they're going to go with Azure because they're going to get a good deal. It's all a money thing, right? They've already got affiliates with Microsoft. Microsoft's going to give them quite a big discount on their Azure bill, I'd imagine. So generally you don't get a lot of choice as to which one you pick. They're all trying to differentiate themselves. I noticed there was another question popped in. I don't know if we'll come to it later around what's the emerging tech. I think the thing is they're within the cloud, they're all looking for this USP. They're all looking for the next thing. And there's a few of them knocking about. So if there's a specific use case for the new USP, then I guess you have to go with that. But generally, they're all much of a mustness. They've all got the same sort of services. They've all got some function service, Lambda in AWS, cloud functions in G Cloud, service functions and just functions. I can't remember, but they're all similar technologies, just got different names.
Do you find, just to jump in here, and maybe from James, from your perspective, I suppose it's different organizations dealing with different scales of people. Do you find that you yourself, if asked to recommend something, sway towards one thing more than the other? Or are there genuine instances of where one is going to be good for something versus one going to be good for something else?
Yeah, it really depends what it is. If you can split it up into small bits, small jobs, and you're not doing something like streaming data, as Mark and Dan mentioned, then I would try and push them towards serverless. But if it's not a good fit, it's not a good fit, and you just have to be upfront about that and design the right solution. Yeah, you do have to not have been burnt by, but you need to see what the potential pitfalls are around serverless before you jump into a big build.
Okay, brilliant. And possibly related to that in terms of providers and tools, that type of stuff, Zach asked a question on the Q&A around fears around platform lock-in with serverless approaches. That's a new thing to me. Is that a concern?
It can be. Replatforming is an expensive thing to do. Generally, you don't see it happen very much unless you're like Parler and you've got inflammatory content and things like that. You probably wouldn't want to replatform just to save a few quid because it costs more than that. So lock-in for me, it's not really a problem, I don't think. But we are an AWS partner, but yeah, I don't know. I'd be as happy using Google.
Like vendor lock-ins, it's not a problem, but it's a thing that happens. That you get these tech agnostic languages like Terraform to say, oh, let's use Terraform for everything, and therefore it's cloud agnostic or platform agnostic. But actually, you tend to have to write all of the adapters, all of the resource managers that you write in Terraform are cloud agnostic. So it's a fallacy that you can't be locked into the cloud you pick, isn't it?
Yeah, that's it. Or you'll have SQS or S3 tied in. So even if you abstract one bit away, you've still got the rest of it to move. So.
Yeah, or IAM as well. I mean, everything's access-wise, rules and permissions. You're still going to have to replicate that in the other one. So,
Good Good stuff. And Dan, while I've got you, there was a question from Aidan, and I heard you talk about AWS Aurora, but the question is, I suppose, to the wider panel as well, have any of the panel used AWS Aurora to implement MySQL on a serverless level? And if so, are there any pros or cons of using it, in your opinions?
So we do that now, actually. So our main kind of curb product is a MySQL serverless Aurora database. And it works pretty well. It's just a normal MySQL database. We have all the advantages of being an Aurora database. So RDS handles all the backups, auto scaling for the database, version maintenance, all that stuff that we don't really care about. Replication as well, so automatic failover to another region or another, not another region, but another, ABC kind of area if we need it. There's a couple of things I guess you need to be aware of. So in using serverless Aurora, so it has this kind of go to sleep thing when you're not using it, but then there's about a 25-ish second thing to wake it back up again. So if you're using it for a web application, you can't really, because it's not going to respond in time. So you either have to have it running all the time, which is actually what we do. So we don't actually let it go to sleep. We just have at least one instance of it running at all times. Unless it's a dev or staging environment, in which case we just let it shut down. But the advantages of using SQL over something like Dynamo at the time for us were better. As we said, if you want to use Dynamo, you need to know your access patterns at the start of the project, and we didn't. So it was something that we kind of had to go for. And also, they came up with this new thing called the Data API. Which was a nice kind of, it's just another API call from your Lambda to your database. You didn't have to set up a connection, username, password thing to your database, and then execute your query. AWS abstracted all that into their Data API service for you. So it manages all the connections. So even if we spin up to, like 1,000 Lambdas, each one needing a connection to the database, the Data API service handles that for us. And then if a Lambda for some reason times out or crashes, that connection's not, strangled and just, left to wither. The Data API, handles that pooling for us. So there's some definite advantages to using Aurora, but yeah, you have to be aware of I think the timings on it as well. And it is more costly. It's about twice the cost of a normal instance as well.
Okay, brilliant. Mark, James, anything to add on that from your experience?
Yeah, I guess not Aurora, but I guess if you're looking for a sort of SQL database in the cloud, I mentioned just before about they're all looking for their latest USP. Google launched middle of last year, start of last year, Cloud Spanner, which is a high availability SQL-like database. It's not true SQL, but actually it's a relational database. And it uses atomic clocks to sync and has transactional security, which is actually quite a nice thing to look into. But I would jump in there if you've got Uber Books, because it's not cheap. It's about $800 a month for one instance, and you usually just 3 to make a cluster. So you definitely wouldn't be on Dan's sort of budget level if you jump in there. But if you've got an application where you need that sort of transactional security in a sort of serverless environment around a relational database, then it's a great product.
Yeah, no, we use Aurora Serverless. Using something like RDS is great because it really saves you bacon. We work with an internal team. It's another company, and it's surprising what in-house devs could do sometimes. Apologies if you're watching. He knows he's messed up. But they deleted a very large 300-400 gig database in a few seconds. But RDS is great because you can just jump back to any 5-minute interval. You can spin up a new instance and then just direct the traffic across. Nice and painless, and yeah, a lot of heartache removed, definitely.
That's quite interesting. So there's a question coming here from Mark Stevenson. It's a fairly long question, but I'll put it to all three of you. Can you explain the adoption sort of learning curve to serverless within your organization? And how long did it take your developers to learn the new patterns? And how long before these new patterns and the usage of these patterns meant they were more efficient and resilient as a dev unit?
Well, that's quite a big question. That's quite a big question. I mean, I guess software development is fractal, right? In my view, the same concepts apply if you're talking about a cloud function to actually writing a function. You want some specific things, and from that function, you want to make sure these days that it's pure and you've got no side effects. If you can help it, you're going to want to think about transactional security when you're updating data. You're going to think about state. I guess the shift in terms of new patterns and paradigms, a lot of the sort of functional type serverless with functions architectures that we've come up with have been event-driven architectures, and I guess the use of functions in cloud is not the hard thing to get the head around. It's that sort of eventual consistency that comes with event-driven architectures and how you manage state when you need state and that sort of thing. And yeah, that's hard. That's really, really hard actually. It takes some time, but actually it's one of them things that you kind of see it overnight. It just clicks. Like people don't get it. They come in next morning, they got it, and they're like, yes, epiphany. This is where we should be. It's hard though. It's hard. It's not an easy thing. That's certainly my experience anyway. What about Dan and James?
Yeah, it was. It's a different way of, I think, thinking about things and putting an application together. You know, you don't just have like a big Django lump. You have a bunch of stuff kind of all over the place. So understanding the architecture is, I think, a challenge sometimes. And it helps if you have a nice up-to-date kind of architecture diagram. You can see, oh, this goes here, this goes here, this goes here. Keeping that up to date is probably one of the, I guess, bigger challenges on a project. In terms of kind of learning patterns, there's a guy named Jeremy Daly who has written a couple of really good blogs on very specific serverless patterns. I think he's got, I don't know, 30, 40, 50 different patterns kind of nicely kind of diagrammed and laid out and talked about. So I'd definitely go there first if you're looking for something kind of pattern specific. And then I guess, you know, the usual kind of rules apply. If you want to learn something, use it, you know, play around with it, try it out. AWS has a great free tier. You know, you probably won't get charged anything for about a year, you know, just playing around with different things.
Yeah, I'd echo that from Dan. Yeah, there's a million free requests a month, I think, on the free tier, and just getting devs to play around with this tech gets them more excited about it when they realize they can actually deploy things themselves and sort of pull themselves up by their own bootstraps. It's quite exciting, and think, oh, I can actually run this quite complex thing in a really simple way.
Brilliant. Okay, and another pretty diverse question, but in terms of this coming year in the future being all about serverless, what things are we going to see this year in terms of? Sorry, I've just lost the question. It's just disappeared on me. Give me a second.
That was the one from Stephen Lindsay, wasn't it? I think.
Yeah, sorry. Yeah.
I thought it was quite an interesting one. Yeah. I don't want to jump in first, or should I jump in first?
Yeah,
I guess since I'm talking anyway, I'll jump in. I guess there's a lot of things. I think, in my view, some of the cloud providers now are starting to provide some quite mature back-end as a service type architectures, which are, I guess, an easy entry point into cloud. In the past, it used to be one of these things where I'm going to use Google again because that's where most of my experience is recently. Google had a thing called Firebase. I'm sure everybody's heard about that, and that's kind of a back end as a service. That used to be a separate product, but that's actually now just a very, very small window over the top of, I guess, the full suite of Google services. And I think from large enterprises, there was always this they didn't want to go straight. They didn't want to go with things like Firebase because they were viewed as more the hobbyist or the front end or the app development type tool. But actually, they're a great way to get started. And I think they're starting to mature now. There's Amplify in AWS. Azure doesn't have anything yet, but they're talking about something quite similar for mobile development. I think they're starting to mature. I guess the other thing that I've seen more recently is I mentioned that actually a lot of these architectures look like flowcharts, like workflow diagrams. And codeless is becoming a thing. There's a lot of these codeless type tools popping up now. So we've got serverless. We're looking at codeless now, where you can pretty much just take your flow chart as you would draw a flow chart and just draw that, and it will do the functions for you with some simple business logic. So codeless is a thing. And then I've already mentioned Spanner. They're always looking for the latest new tech. So high availability SQL databases or relational databases are a thing. I mean, that's the things I've seen. They're a competitor, but I'm going to recommend it anyway. ThoughtWorks Tech Radar is great for this sort of stuff.
Yeah, it is. Just to the other two panelists, the question there was, what are the emerging technologies to look out for?
Yeah, I think definitely low and no code options are really sort of picking up pace. I guess my only sort of warning would be, especially with things like amplifiers, that when you sort of run out of runway with it, you can't really unpick it and figure out what's going on underneath. We were trying to do some prototypes for some for scaling a quiz to lots and lots of participants, and we were running up against these limits that aren't documented in the system. So it's sometimes like it's like a nice facade over all this stuff, and it's just magic and shiny and works. But when you actually come down to use it, you might get burnt. So just tiptoe carefully into those, but they will mature, and I'm sure they'll all be amazing.
Google's using it probably the most mature of the lot. Firebase has been around for a long time. I know I've heard a few people speak about amplifying that way, but it's getting better. And I don't think it's got anything yet. No, that's possible. Yeah, I agree. I totally agree.
Okay, and I think that Dan touched on this a little bit earlier, but another question around serverless having many advantages for developers, but what other roles are important for a successful serverless project?
I think your architect. Yeah, if you don't have a plan of how to build, the whole application, you're going to very quickly run into a lot of trouble. So what we usually do at the start of a project is a mobbing session. So we don't have like a defined architect in our company. So we just have a really great team of developers. So we kind of all get together, figure out kind of what it is we want to build, draw it out, think it's going to work, and then just kind of go and build it. But you need a plan to start with. You don't need a big design up front kind of thing, but you need at least a starting position and a kind of know which way you're going to go.
Yeah, and I think you mentioned you'd expect your developers probably to do the role of a DevOps engineer and a QA or testers. Do you see those as being needed as dedicated roles? Or
I don't think so, no. We kind of have, I guess, a very typical agile sort of scrum team, back-end people, front-end, mobile, QA, product owner, designer, and then that's the team. So everything they need to do is kind of covered by every discipline within that team. I don't know if I mentioned, QA person. But we've changed the role of the QA person in the team as not somebody who just runs some tests, but they're pairing with the developers and telling the developers how to write the tests and what they should focus the testing on, rather than just running the tests. Because then I think the role of the QA is changing quite a lot into more automated testing as well. But I think that takes a lot of skill out of the QA role. They're not just there to click buttons and run some tests. I think they have a lot of valuable input in how the application should be tested and where it should be tested. There's a lot of expertise and skill in that area, I think.
Yeah. Anybody else have a view?
I've got nothing to, I guess, what Dan said. I mean, Dan's, I guess, describing, our utopia in consultancy, to have cross-functional scrum teams where everybody can do a bit of stuff and everybody has a specialism or a craft, i.e. they're all a team working together, right? But someone might have more experience of architecture, someone might have more experience of testing. And actually, Dan raises the point about test engineers. I think the more broad the skill set of your test engineers, the better, because actually what you really want is you want test engineers who will prod your solution in ways different to how your developers prod it.
Yeah.
You want someone who will prod it like your users will, because you guarantee that you can test to the hilt, and then your product will go to somebody who's not used to technology or uses technology a completely different way. They'll press a button and it all blows up. So actually you want that diversity in test of your test engineers and a diversity of thinking. Yeah, tests are important. That's how I Utopia. Dan mentioned DevOps before. DevOps is a real big one for us, because within these large financial organizations, pretty much DevOps, what they've done is just renamed their ops team DevOps. It's not really DevOps. It's just an ops team with a different name. I'm not going to mention the actual client, but I do remember rocking up to the client one day, and I met the head of DevOps, or head of ops. It was basically, yeah, you can come and you can do whatever you want. You can do all the CI/CD stuff. But the thing you have to remember is it's our playground, and you'll play by our rules, or you won't play in the playground. That was a really, really nice first conversation with that guy. We got on swimming. DevOps is really important for this stuff.
I suppose talking about that, I know we've touched on it a little bit before, but one for all three panelists. You know, do you guys have in your organizations a position called DevOps engineer? Because I've heard it's a culture, it's not a position. It's
exactly. No, we have.
You know,
we have I can't remember the actual job title. There's senior cloud engineer, but that's more around cloud specialism rather than DevOps. Our developers do DevOps. That's the whole point of being called DevOps in our view anyway. I don't know about Dan, you've kind of said.
Yeah, I think it kind of, and I don't want to bash consultancies, but
No, do it. We know each other well enough for you to bash consultants.
I mean, companies have come out and said, well, we don't have any specialty in DevOps because it's the new kind of big thing. We need DevOps people. So consultancies have kind of said, oh, we'll sell you some DevOps people. And it's the kind of the new agile, isn't it? It's the latest thing to sell. And it's unfortunately, I think, not quite right. It's a skill that a person needs to have, I think, within a team. Yeah. And more now, I think it's part of the developer skill set to be able to do that kind of stuff. Whether it's CloudFormation template or Terraform or whatever, if you write some code and you don't know what that code's going to do in an environment, I think that's a big problem. Your developers need to know what's going on. If you're just going to hand that off to some other person, same with QA. If I write some code and hand it off to a QA person to go and run the tests, I haven't done my job properly. I need to know what's going on with it.
I mean, certainly from a recruitment point of view, a few months ago, if you were a dev engineer and you made yourself a DevOps engineer because you knew a bit about DevOps, you could command a much higher salary. Seems to be the buzzword at the moment.
Yeah, and that was one of the reasons for the question, because as recruiters, we often get jobs which are DevOps engineer, which is some sort of blend of developer or infrastructure or swaying between the two. And well, to be honest, it just makes our job much harder. But James, I don't know if you've been sat there fairly quietly. I was worried you might actually have DevOps engineers in the team now.
We do have someone that looks after Kubernetes, because it does need a bit of love. But generally, devs do know enough about the DevOps side to integrate that into their project. So yeah, it's a bit of a blend. And we do get people doing their own QA. Big fan of devs pull requesting each other and making sure that they're actually doing a proper QA. We have people that do testing as well, but that's more around as a new user with a fresh pair of eyes, does this sort of work, rather than is the code shit or not?
Yeah, absolutely. Great stuff. Question that we often get when doing these panels, what would you say is the sort of biggest mistake or error you've made on a serverless project, or something to avoid if you're going into this for the first time, that could really get you in a bit of bother?
Myself,
to the floor.
What have you done?
So the biggest thing we had, we ended up had a recursion issue where we had a function triggering a function. It's the classic serverless thing, right? Where a function writes to a database, where that database triggers the same function that wrote to the database that causes it to write again. And you end up in a situation where basically you actually just have to tear everything down to stop it before you literally spend quite a lot of money. Luckily, we had budget limits and stuff on that particular project. It wasn't me. I'll just say it right now, but it was on a project where basically the function calling a database which triggered a function, the same function that wrote the database. That was horrendous. And actually, the worst thing is we were using Google Firestore as the database as well, which doesn't allow you to delete the whole. You have to either tear down the whole database or delete records individually. So we end up with quite a lot of records in there, like millions of records in there. And actually, you can delete them. I think you can delete them in batches of 300. I think that's the max. Or tear down the entire database, which we didn't want to do because there was other stuff in it. So yeah, it was pretty horrendous.
A couple of weeks ago, our front-end dev wrote an infinite loop in his code, which made GET requests to the service. And we didn't notice for about 5 minutes, after which there was about 550,000 requests in. So we quickly told him to shut it down. But, serverless architecture, it just handled it. So, it didn't really know anything was out of the ordinary. Whereas, a typical kind of setup with service, that would have fallen over after the first 20 seconds.
Scaled itself massively and cost lots of money.
Yeah, exactly. Yeah. Thankfully, we didn't. I think it cost us maybe $10 for that lesson. But yeah. So $10 for 500,000 requests in 5 minutes is quite good. I think we were paying more for the burst capacity than the actual requests themselves. But yeah, it's like Mark said, you kind of, I guess, need to have guards in place. I think that's one of the good things you can now do with AWS. You can put in some limits so that you don't overspend and have problems like that.
I think a big mistake that we sometimes make is execution time could sometimes creep up, and that'll be set at the default until you hit it, and then things start falling over. So just be wary about that. Especially if you're using like third-party APIs, and as you hammer them more, it's them that slow down that causes your execution time to sort of topple over the limit.
Great, excellent. Thank you very much. And we'll go through the final few here on the Q&A. So we've got another one from Mark Stevenson. With you mentioning multi-cloud, I believe this is an open question. With you mentioning multi-cloud, do you have any reference architectures or workflows whereby you can write the functions once and have them deploy to all vendors? And how are you managing failover or scaling between those vendors?
Yeah, we're not. None of the multi-cloud projects I've worked on, we're not. They tend to be, so actually, I lie. Some of the business logic is shared, and it's pretty much JavaScript they're using, or we're using on this particular project. The business logic was shared in a NuGet package, but obviously the wrapper around that business logic, the bit that maps the triggers onto the actual function calls was cloud specific. We weren't handling any failover scaling between two vendors. That was a manual thing, if ever it needed to be done, and it was kind of a worst case scenario. And actually, there was a lot of things going on that weren't true multi-cloud, because there was some things that they were storing in one provider that wasn't being stored in the other because there wasn't a service that they wanted to use in the other. Perfect example, they were storing a lot of stuff in S3 in AWS. But actually, if AWS had gone down, like God forbid, the whole world would stop anyway. So that would be at least your worries. But if AWS had went down or whatever in that region, then you wouldn't have had access to that data at all, because it was only in one of the clouds, even though they were talking about multi-cloud. I guess some of the things they were doing is they were using Apogee Gateway to route traffic across both cloud environments. So that was quite good. Again, Apogee is a great product, but again, it's another quite a pricey addition to your cloud tool set. And like I said, there's no failover or scaling between the vendors. There was just scaling within each of the vendors' clouds. If Mark's actually got any strategies around that, I'd love to hear them as well, because I think that's quite a widely blogged about topic. Not yet.
Not yet.
If you come up with something, Mark, I'd love to hear about.
I think the general thing is don't, if you can.
Yeah.
And if for whatever reason you absolutely have to, I think what Mark's got is probably the closest thing you can get. There are there's serverless, serverless framework that can go to multiple clouds, but there's nothing, you just send it to AWS, send it to Azure or wherever, but it's not like it's, they're not connected in any way. They're two totally separate things. So you still have to, if you do want to somehow join them together, you're still going to have to do a lot of manual steps, and manual scaling, manual failover, all that kind of stuff. I mean, for the 3 minutes that AWS goes down a year, is it really worth putting all that extra effort in? The payback is not, in my opinion anyways, not worth it.
Tends to be more cross platform and cross vendor traffic. You'll be doing something with another team in another department in a large organization that happens to be using Azure and you're using AWS, and therefore you actually have to manage the traffic across the vendors. But it's not like a duplication of a product generally in two environments. We hardly ever, and two vendors, we hardly ever see that.
That would be an absolute nightmare to debug, everything.
Yeah.
Good stuff. And then we've got just a couple of questions left. There was one that came in, I believe it was during your talk, Dan, possibly when you had the architecture diagram up from chat, about what sort of load testing results did you get for that architecture?
So this is probably going to surprise everybody, but we don't do load testing, mainly because we kind of expect the AWS infrastructure to just handle stuff for us. So I don't really want to spend effort or time or money on testing the AWS infrastructure. I kind of assume that they've already done all of that for me. So for me, one of the advantages of doing a serverless architecture is that it's done that. I don't need to. Saying that, we do some things around what we call capacity testing, which is kind of very short run kind of run-throughs of a slightly higher load than maybe we think we're going to get for maybe 20 minutes or something, to make sure that our own kind of business logic can handle the type of things that we're going to be doing. So, if we put something into Dynamo and there's a stream off the back of that that's going to go and do something else that's then going to go and whatever, we want to make sure that all that flows in a nice kind of, in a nice way. We're sending WebSocket updates out, and then something gets kind of triggered on the back of the WebSocket update. All that, that's the kind of stuff you need to make sure kind of plays nicely together. For very specific load testing, we don't bother, don't do it. I don't see the need for it, to be honest. But again, I'm probably in the minority on that. I know it's a requirement for probably a lot of the governments and banks and things like that to have that kind of traceability and audit stuff. But I think if you're just testing public cloud infrastructure, there's no point.
Okay, great stuff. We're coming on to the last question now. Just a reminder for everyone that we've posted the Slack channel link in the chat, where you can get access to Dan, Mark, and James, and follow up on any of the resources as well in the community there. But final one from Aidan. Did you look to use the serverless framework for development, as it offers access to all major cloud providers, but abstract some of the high-level knowledge away from the developers in the dev process? Or are there any other dev tools you'd recommend? Let's go to you, James.
Yeah, so we've used serverless framework since its early days, back when it was called JAWS. I think it's really good for developers getting going, but there is that sort of law of leaky abstraction, the famous Joel Spolsky post. Basically, you need to understand all the way down when it goes wrong. So underneath on AWS is CloudFormation. So when you get that hairy problem or the thing you need to debug, you're going to have to understand what's underneath anyway. So it does save you time in terms of getting up and going and getting a good feeling that you're being productive to begin with. But I think eventually you're going to have to learn all the bits underneath anyway. So it depends what kind of person you are. I guess if you if you know you're going to learn it eventually, you might as well start with cloud formation maybe. If you'd like the abstraction over the top, you can use that as a sort of, I guess, like a scaffold to get going. But eventually it'll get you, and you'll have to learn all the other bits, unfortunately.
Great. Dan, Mark, any final words on that or anything?
If you've not used serverless before and you're going to use it in a project, speak to somebody who has, or play with it for a good 6 months first. I think that's probably fair.
Yeah, great piece of advice, actually. We got, you might have heard Yan-Chi, or Yan-Chui. We had him for a day. Well worth the investment if you can, just to kind of bounce ideas off and kind of, you know, test ideas out and see if, you know, they're going to work before you actually invest, you know, real money into building stuff. Around the serverless framework, I used it once on a training course. I wasn't a huge fan, I'll be honest. We just use the AWS SAM tool for kind of packaging, deploying, but that has a couple of drawbacks as well around mainly the packaging element. We actually have like a pre-packager before we run the SAM commands, so we only put into the Lambda things that you know that Lambda needs, whereas SAM kind of bundles in everything, but then only uses the handler of the code that you tell it to. What else? But yeah, definitely play with stuff. You know, learn. You know, it's the easiest way to kind of figure out what's going on.
Good stuff. Well, I believe that brings us to a close. So I'd just like to take this opportunity to thank the speakers, Dan, Mark, and James, again for your time. I know you're incredibly busy, guys. Like I say, we'll all be available on the Slack community for any follow-up questions or shared resources. We'll also make the recording available for any colleagues that couldn't make it, and post that on the TechSpace YouTube. But just, I suppose, as a final point, thank you from me and the guys for joining this installment of TechSpace. We run these events for the community, so happy to take on board any feedback, how we can make them better, and also any ideas for what you'd like to see next. But thank you very much.
Thank you very much.
Thanks for
Thanks for having me.
Thank you, guys.
Thank you. Bye-bye.